Welcome to ePathshala PG courses of Computer Science. In Web Technology subject, today we are going to see the last module, JMS. JMS is a continuation of the earlier module. We have seen in the last module itself what is Java messaging service. In addition to that, today we are going to learn about the Java messages and its formats and the type of messages. And also we are going to learn about the queue concepts which are available in JMS. To learn an example, that is we are going to learn an example of how to send message and receive messages using JMS. Apart from that, we are going to see some fundamentals of MVC also, where MVC stands for Model View Controller. In the last session itself, we have seen this JMS programming model. I told you that a connection factory has been created earlier. From the connection factory, connection gets created, where the connection creates a session. The session is responsible for creating the message producer as well as the message consumer. The message producer sends to the destination as well as the message consumer also receives from the destination. So, both of these people, that is sending as well as consuming, the destination is responsible for them. So, this is what we have studied in the earlier session. Now, let us start with the messages. Yesterday, let us in the last session we have studied about the connection factory, connection, session and destination. In this session, let us study about the message, message producer and message consumer. Now, let us see what is a message. JMS application produces and consumes message, that we have seen. The message interface is the root interface for all JMS messages. So, basically there are 5 types of messages. We can name it as bytes message, text message, object message, stream message and map message. Now, this message has to be created only from the session object. So, earlier we have seen how to create a session object. From the session object we are going to create a message. That is, the message belongs to text message. The text message has been created from the session object. So, we are seeing that session dot create text message of the handle, that is the instance has been given to the handle message. In that message handle we are setting the text as hello EJB3 MDB. So, this is the way in which we can create a text message. Similarly, if we want to create a byte message, again we can use the method create bytes message of over the session handle. If we want to create a map message means it is nothing but a key value pair. Byte message means every message comes in the form of bytes. So, again for the map message, the create map message method has been called over the session handle. Then stream message, for that create stream message method is available, again this has been called over the session handle. And if we want to create the message as an object, then that create object message method has also been called over the session object. Okay. So, if we go through the message interface, this message interface has been extended by 5 different messages, that is text message, byte message, object, stream and map message. All these people are subclasses of this message superclass. Now, we have seen that the message producer produces the message and places it in the destination. On the other hand, message consumer consumes this message from the destination. This is what we have seen earlier in the programming model. Now, a message producer is an object which is created by the session, and this is used for sending messages to the destination. At the same time, message producer comes in 2 forms, that is, either we can use the queue sender or we can use the topic publisher. That is, the message can be used either in the form of queue or in the form of topic, or the destination consists of queue and topic. The messages will be stored either in queue or in topic. So, that is why both the queue sender as well as the topic publisher extends the class message producer, that is, it extends the interface message producer. Now, we can see how to create a handle for the message producer. So, already we have seen how to create a session object. Using that session object only we can create a message producer. You can see that message producer is equal to session dot create producer of destination. Okay. In create, that is session is an object which has been created earlier. Using that session object, create producer method has been invoked over this session object. So, create, the handle for the create procedure is going to destination is passed as a parameter to the create producer. Again, this sends an return object called as producer. This is a generic method. Suppose if you want to be more specific for a queue, then you can create a queue session. In the queue session, you can create a sender. So, in which the handle is available with the queue sender variable. Suppose instead of queue, if we want to create a topic, then we have to create, or we have to call the create publisher method over the topic session, and the topic publisher variable will be created. So, once the message producer is created, we can use the following methods. Either, that is, if we are using queue, then we have to call the queue sender object dot send of message, or we can call the topic publisher object. Over that we can publish the message. So, topic publisher dot publish of message. So, these two methods are used for sending the messages, or we can call it as publishing the messages, depending upon the type which has been used as queue or topic. Now, let us discuss about the other type, that is the counterpart, which is message consumer. Again, message consumer is an object. This is created by the session. This is used for receiving the messages which has been sent to the destination. So, this implements message consumer interface, whereas this implements message producer interface. This implements message consumer interface. The message consumer allows the JMS client to register its name in the destination with a JMS provider. Why this is required? The message consumer registers itself saying that if a message reaches the destination, then I require this message. So, that is why it is registering with the destination with a particular JMS provider. Once the provider has given that message to the destination, the consumer automatically consumes it from the destination. Now, the JMS provider manages the delivery of the messages also from the destination to the registered consumers, who are all the consumers who have registered to the destination saying that I require this message once it is produced. So, the JMS provider is responsible for the delivery of this messages also. The PTP form of message consumer, we have seen already that point to point delivery model. If we use that, then the message consumer implements queue receiver interface. Suppose if we use publisher subscriber model, we have seen in the last session itself two models are available, point to point model as well as publisher subscriber model. If we use point to point model, then it makes use of the queue receiver interface, whereas if we use publisher subscriber model, then it makes use of the topic subscriber interface. So, you can see the code snippet which pertains to the message consumer. So, we can use a queue session to create a receiver for the queue. So, first we are going to see how to create a queue using the queue session. Then a topic session, this is used for creating a subscriber for the topic. You can see that a variable called queue receiver who belongs to the, this is the variable called queue receiver. This belongs to the class called queue receiver. This has been created from the queue session over the queue session handle dot create receiver of. This is a method which has been called over the queue session object by passing my queue as the parameter over it. Now, we would get a message consumer. This message consumer is called as queue receiver. Suppose instead of queue receiver, if we want to make it with particular to topic, then we can create a variable called topic subscriber. Here topic subscriber is going to be the message consumer. The topic subscriber, again it has to be created from the session called as topic session. In the topic session, we are going to call the create subscriber method. So, either we can follow the queue receiver or we can follow the topic subscriber. Suppose if we want to create a durable subscriber, that is which may last for a long time, then we can call the method called create durable subscriber instead of create subscriber. So, once we have created the message consumer, it becomes active and it is ready to receive the messages. So, these are the two message consumers, either following the topic or we can follow the queue. Now, let us go through the message consumer, but here in the message we have just seen the creation of a message consumer. The creation of the message consumer is either topic subscriber or queue receiver. Now, using this handle of queue receiver, how to receive the message, that has been done here. So, this method, the receive method, can be used at any time after we call the start method. You can see that first we have created a connection earlier in the last session. So, the connection has to be started. After the connection has been started, the queue receiver handle, this is what the queue receiver object. Over the queue receiver object, we can call a method called as dot receive off, or topic connection has to be started. Over the topic subscriber, we can call dot receive of 1000, which says that it can wait for 1000 seconds, that is timeout after a second. So, this is a synchronous method of message conception. This is a synchronous method of message conception. Here once again you can see that the receive method can be used to consume a message synchronously. Only if we want a synchronous method, we would make use of this receive method. So, this receive method comes. Otherwise, here also using the receive method, this is going to be a synchronous communication. Suppose if we want an asynchronous communication, then we can make use of the message listener. So, let us see what is a message listener, because using the message listener we can do asynchronous message conception. So, a message listener is an object that acts as an asynchronous event handler for messages. Yesterday, that is in the last session itself, we have seen what is asynchronous and what is synchronous. So, this is an asynchronous event handler. So, the message listener is not specific to a particular destination. So, it implements message listener interface, and this message listener interface consists of only one method, which is called as OnMessage method, where the parameter of the OnMessage method is going to be MSG, that again belongs to the message data type. So, OnMessage method should be capable of handling all exceptions also. Now, let us see an example how to implement a message or how to invoke a message listener over the topic listener. So, topic listener is again an object. This has been created from the class of topic listener. This topic listener has been sent as a parameter to invoke the method set message listener of, whereas the set message listener has been invoked over the topic subscriber. Topic subscriber is this method what we have seen earlier. This is what our topic subscriber. Over the topic subscriber, instead of receive method, here we are going to call the set message listener of topic listener. This is what the usage of message listener with respect to the message consumer. Now, there is one more thing called as message selectors also. Message selector means this is used for filtering out the messages which is received by the application. Message selectors, it assigns the work of filtering messages to JMS rather than to the application. That is, with respect to JMS, it tries to filter out the messages. This message selector is going to be a string. Some people would refer it to as SQL92 string. It consists of an expression. So, a message selector, but it does not select message on the basis of the content of the messages. Okay. So, this is one component which is available in JMS, which is called as message selectors. Now, let us look through the format of the message or body of the message, what the message would consist of. That is what we are going to study now. So, the ultimate purpose of JMS application is to produce and consume messages through software applications. That is what we have seen. So, every message is going to have some basic format. So, that format is going to be simple, highly flexible. It creates messages which match formats on heterogeneous platforms also. But let us go through the significant parts of the messages. There are three significant parts in a JMS message. The first one is called as header. Header means it consists of predefined fields. Then second one is called properties. Property is an optional one. This consists of additional fields. Apart from that, body of the message will be there. Body of the message represents you the actual message content. Now, let us go through the header of the message. So, a JMS message header consists of a number of predefined fields, and every field is going to contain some value. This is used by both clients as well as the providers. For example, we can see that every message is going to have a unique identifier. This unique identifier is represented in the header field JMS message ID. The value of that is, there is one more, this is one of the header field which is called as unique identifier, which is called by the name message ID. There is one more header field which is called as JMS destination. This JMS destination represents which queue or the topic in which the message has to be sent. So, the destination is going to have which queue or topic where the message is targeted to. So, the other fields, apart from this message ID and destination, other fields also present. The other fields may contain timestamp, priority level, etc. So, apart from this, each header field is going to have some associated setter method as well as getter method. Let us see that one by one. Now, let us go through the header field. Earlier I have explained you two fields, that is message ID and destination. Now, let us go through all of the header fields one by one. So, the very important field is JMS destination. The destination to where the message is intended to or targeted or to be sent, that is given by this header field. Again, this header field is set only by the send method or publish method. The second one is called as delivery mode. Delivery mode means it describes whether it is persistent or non-persistent, that is the message which is delivered is going to be, or the mode of delivery is going to be persistent or non-persistent, that is it is whether it is going to last for a long time or for a short time. Again, it makes use of send or publish method. Then JMS expiration, this is one property, this gives when the message is going to expire, what is the expiry time of a particular message. Then priority we can set, that is done using JMS priority header field, whether high priority message or low priority message. Then JMS message ID, that I told you already that it is a unique message identifier and it should be prefixed by the term ID. Then JMS timestamp. Timestamp tells that the exact timestamp when the message has been sent by the sender. So, all of these header fields can be set only by using the send method or publish method. Apart from this, some more header fields also available. They are correlation ID. Correlation ID means this ID is used to link the messages among one another. Then reply to is there. Reply to means destination to which a reply has to be sent. See, already some destination has been there. If the message has been sent, if it wants an acknowledgement to which it has to be replied. Then type. The identifier indicates what type of message this is going to have. Then JMS redelivered indicates that a message could be a duplicate or not, that is set using this header field. So, the first three header fields are set by the client, whereas the last one is set by the JMS provider. This is about the JMS message header. Okay. Apart from that, now let us look at the properties of the JMS message. We have seen that it is going to have three parts, the header part, properties part and body. We have seen the header fields of JMS. Now, let us look through the properties of JMS message. So, the JMS message, I told you that the properties, it consists of already optional fields. This optional fields can be set by the client before the message is sent also. But some properties can be predefined. For example, JMSX user ID specifies the user sending the message. And the values which is used in the properties can also be of different types, either boolean, byte, short, int, float, double, strong, anything can be used. Then some predefined properties can also be used, but generally we would say that the use of predefined properties or user defined properties, both of them are supported and they are optional. This is about message properties. Now, let us look through the last significant part of the message, which is called as message bodies, body of the message. So, the body of the message can be used in any one of the 5 different formats which has been listed. The first one is called as message format. If you use message, the content is empty because it is simply going to have the header as well as the property, it does not have the body of the message. But if you use a stream message, the stream of apart from the header and the properties, it is going to have a stream of Java primitive values also. What do you mean by primitive values? This is what the primitive values, which is of boolean, byte, short, int, float, double. So, any values which belong to this type can be called as primitive values. Then map message, if you to go through map message, apart from the header and properties, it is going to have a set of name value pairs also. Like a map, it is going to have the content as a set of key value pairs. Then text message, in text message the body is compulsorily going to be a string. Sometimes it may be an XML document also. If it is an object message, then definitely the message content is going to be a serialized Java object. If it is a byte message, then the content is always going to be a stream of uninterrupted bytes apart from the header as well as the property of the message. So, these are the three significant components, or these are the three significant parts of a JMS message. Now, using this JMS message, we have seen the types of message, formats of message, everything. Now, let us look through how to send a message as well as how to receive a message. Okay. So, for example, we want to create and send a text message, means we can use the following statements. First, we want to create a message. The message variable belongs to the class called as text message, whereas this message variable should call upon a method called as create text message of, where this create text message of can be invoked only on the session object. Since we are using queue object here, we are making use of queue session object. Only over the session object we can call upon the method create text message of. Again, in create text message of, we are sending the message handle. Over the message handle, now we are going to set the text, that is which text we want to send to the destination, that has been set here. Now, once the message has been set, using the send method, this message can be sent to the destination. Again, for sending, we have to invoke this method on a particular sender object. Already we have seen there are two things, either queue sender or topic subscriber is there, topic publisher is there. So, the publisher or over the sender we can send this message. Similarly, we can see how to receive the message also. At the consuming end, the message arrives as a generic message, then it has to be casted to the appropriate message type. So, here we can see that again, for the counterpart of queue sender is going to be the queue receiver. Over the queue receiver, the receive method has to be called upon. Once the receive method has been called upon, the handle is assigned to the m variable, where m variable is nothing but it belongs to the message data type. So, once the text message is obtained, using getText method, we can retrieve the message and it can be displayed using system.out.println method. Here we can send the message using setText method. Here we are going to receive the message using getText method. So, this is an example for receiving a message. Now, the last one of this programming model is going to be the queue browser. So, until this we have seen that the destination is going to make use of either queue or a topic. So, the messages sent to a queue remain in the queue. Let us assume that the mode of representation is going to be queue, or the destination makes use of the queue. In that case, messages sent to the queue remain in the queue until the consumer consumes the message from that queue. So, for that we can make use of the JMS API called queue browser object. This is used to browse all of the messages in the queue and it displays the header value for each message. Now, you can see that again we can create a queue browser, but this create browser of method should be invoked over the session object. So, once a browser has been created, the handle has been transferred to the variable called as browser, where this browser belongs to the data type queue browser. So, now the browser is ready. Okay. Apart from the queue browser, now let us look through what are the exception handling mechanism followed and what are the exceptions followed in JMS. So, the root class for exceptions is thrown by JMS API method, and the exceptions comes under a particular category called JMS exception category. So, there should be a generic way for catching all of these exceptions that arise due to JMS API. So, the different types of exceptions which comes under the JMS exception class or which may arise in JMS that needs to be handled are illegal state exception, invalid destination exception, JMS security exception, message format exception, suppose if the format mismatch, and message not writable exception if the message is not able to set over, that is if the text is not able to set over the message. Then invalid client ID exception if the client ID is mismatching, invalid selector exception, suppose if the message selector is invalid, message end of file exception if the message ends abruptly, message not readable exception if the reading format is not compatible, then resource allocation exception. These are the different kinds of exceptions which may arise, and this has to get handled under JMS exception. Okay. Now, let us see a full program of JMS, how to create a connection factory, connection, session, message producer, message consumer, and how to create a message, send a message and receive the message on the other end. Let us try to study the whole scenario what we have seen with the help of a program. Now, let us explore it with two programs. One is called mysender.java. The other one is going to be myreceiver.java. First, let us explore the mysender.java. So, in order to write some files, we require a buffer reader. Then, in order to get the input, we are making use of input stream reader. Then, we are going to create a messaging service. That is why we are using javax.jms. First, we are going to create a class called as the sender class, which is running on the sender side. Okay. Inside it, first, this we have seen earlier in the last session itself. Initial context has been created. In the initial context, a queue connection factory, that is a variable which pertains to the queue connection factory class, has been created, whereas this has been looked up from the context. Again, in the queue connection factory, we have to create a connection, because we have seen earlier that connection factory creates connection. So, for creating a connection, we call upon a method called as create queue connection of. Once the connection has been created, this connection needs to be started. That is why we are making use of con.startoff. Again, from the connection, we are supposed to create the session. So, that is why we are calling upon this connection object, then con.create queue session of false comma session auto acknowledge. That is the acknowledgement once the message has been received, in that the acknowledgement will be sent automatically. That is why we give auto acknowledge. So, over the connection we are creating the queue session, and the handle is passed on to the variable called session, where session belongs to the class type queue session. Now, we have to operate on the session object. This is what the session object. In the middle, we are going to create a queue structure which is looked up from the context, the queue which belongs to the destination. Now, using the session object, we are going to create a sender. Sender, we call it as the message producer. Okay. So, the message producer has been created using the session object, and it is the handle has been passed on to the object called sender, where sender belongs to the data type queue sender. Now, over the sender, again over the session, we create a text message. This has been passed on to the message object. Now, this message, the message which has been created, this has to be passed on. So, for that what we are doing is buffer reader B is equal to new buffer reader of new input stream reader of system.in. This is nothing but which is going to get the input from the keyboard. So, from the keyboard it reads a line of text using b.read line of. This has been passed on to the string yes. If the yes is equal to n, then the program will be broken. Otherwise, what has been read in the yes variable using b.read line of, that has been passed on to the message object using by invoking the method called setTextOf. Now, the message is ready. This is what the message. Now, the message is ready. This message has to be sent over the sender object. So, this is what we are going to see now, sender dot send of message. The message has been sent through the sender object. Now, the message has been sent. So, we are giving the command that message successfully sent. After finishing all of these communication, we can close the connection, that is why con.closeoff. Then appropriate exception has to be handled using the catch block. So, this is with respect to the sender program. Now, let us receive the counterpart, which is going to be the receiver, that is the receiver who is going to receive the Java messages. Now, public class myReceiver, again this is going to create an initial context variable. In that initial context variable, it looks up for the queue connection factory. Once it creates the queue connection factory F, Using that F, it creates a connections. Again for that it calls Q create connection of, create Q connection of, the handle has been passed on to the CON object. Once the connection is ready, the connection has been started. So once the connection is started, the next step is to create a session. So over that object, create Q session has been taken. Now the result has been passed on to the object, that is session object, which belongs to the data type Q session. Now we are going to make use of the session object. Again in the session object, create receiver of has been made. So create receiver is nothing but message consumer has been created. So the message consumer has been created over the session object and the handle has been passed on to the variable receiver. Receiver is nothing but an object of the QReceiver class. Now again here we are not going to get it, since if it is a synchronous communication, directly we can call the receive message over the receiver object. Here we are going to follow the asynchronous mode of communication. So what do we make is we are creating a message listener. Earlier we have studied that if we want to follow asynchronous mode of communication, then we have to create a message listener. So a message listener has been created. So in order to create a message listener, new my listener of the object, this handle has been passed on to the object listener. This message listener has been set over the message consumer. This is message consumer, which is receiver. So receiver dot set message listener of this handle listener, so that the message listener has been set over the message consumer. Now only through this listener we are going to receive the message, that we can see here. That is public class my listener implements message listener. This is what the object what we have created here. My listener, listener is equal to new my listener of. So we are going through the implementation of the my listener class. So if we go through the my listener class, this implements message listener. The message listener interface consists of a method called OnMessage. So that OnMessage has to be implemented here. So public void OnMessage of message M. So what happens here is, first it creates a message variable or a message object which belongs to the text message type. Now over that message variable get text of, where this MSG has been connected with M. This M is nothing but the message, where this message receives the, where this message has been received from the receiver object. So the receiver object communicates, or through the set message listener, the handle for the receiver object is passed on. So once the handle for the receiver object has been passed on, it has been received through the variable M, which belongs to message type. So there the M has been passed on to MSG. From the MSG we are getting the text, or we are calling the getter method to extract its text. Once the text has been extracted, the text has been displayed. So in order to make this implementation into a runnable version, first we have to run the sender class. Then we should first we have to run the receiver class. Then we have to run the sender class. If both the sender and the receiver class are in live, the sender can send a text message and the receiver can receive the text message and display it. So this is a sample program for the Java messaging service implementation. Okay. So with this I am just ending of Java messaging services, and let me give you some fundamentals of model view controller. So model view controller architecture, which is called as MVC, is available with Java. So everyone who does programming in Java should study or should know about this model view controller architecture. This MVC architecture can also be called as design patterns, or this MVC architecture has been taken from design patterns. First let us see what is a pattern. A pattern means it is a proven solution to a problem in a context. Pattern means it is a proven solution to a problem in a context. So each pattern is a three-part rule. That is, three-part rule means it consists of certain context, a problem and a solution. So that is why we call it as it's a design pattern. Every design pattern consists of three things: context, problem and solution. So in other way we can say that pattern means it is equivalent to a problem solution pair which acts in a context. So three things I told you already, that problem, solution and context. So for every pattern, name of the pattern must be there. Context means it says that in which context this problem occurs. So MVC means it is an architectural pattern. It develops interactive, this has been used mostly for developing interactive applications such as shopping cart on the internet. Now why this pattern or MVC architecture has to come? The reason is user interfaces may change often. Sometimes the model may change, sometimes business logic may change, but most probably the user interfaces changes often, especially on the internet where look and feel is a competitive issue. So the same information has to be presented in different ways also, and most of the times the business logic and data is stable, but the presentation layer needs to be changed. In those cases, if you organize the program in this model view controller architecture, it will be very helpful. So that is why this MVC pattern comes to the picture. Now I told you already that it is of three types: model, view, controller. So most common design pattern is MVC. Model means it does all of the computational work. Computational work means it deals about this is input and output free. This doesn't deals with the input output, but it speaks about the business logic. That is, all the communication is done in the model only through the methods. That is, the method communicates the information. Controller means it tells the model what to do. That is, all of the user input goes to the controller. Then the third one is called as view. View is used to show the results. It is nothing but a window which shows the result to the user. The view can get results from the controller. The view can get results directly from the model. Either the view can get the results from the controller or the view can get the results from the model. So view is used to show the result basically. All of the user input goes to the controller and model is the place where all of the business logic takes place. It is completely free from input and output. So this is one of the architecture which is used in Java. So I am just telling the typical application. Here we can find three fundamental parts: data, view and controller. Data means it is a model. View means it is an interface. This is used to view the data as well as which is used to modify the data. Then operations that has been performed over the data, that is done using the controller. Let me tell about the summary of this session. First, we have learnt about the JMS messages, what are the different types of the messages, what are the different formats of the messages. Then we looked up on a complete JMS example which tells you how to create a sender program and a receiver program and how to send and receive messages among these things. Then we have gone through some of the fundamentals and significance of the model view controller architecture which is required in Java programming. Thank you.